Okay, question 12, the final core question for this paper. So, trees in a forest may be affected by one of two fungal diseases, but not by both. The number of trees affected by disease A, NA, can be modelled by the formula NA is equal to A e to the 0.1 t, where t is the time in years after the 1st of January 2017. The number of trees affected by disease B, NB, can be modelled by the formula NB is equal to B e to the 0.2 t. On the 1st of January 2017, a total of 290 trees were affected by a fungal disease. On the 1st of January 2018, a total of 331 trees were affected by a fungal disease. Part A asks us to show that B is equal to 90 to the nearest integer and find the value of A. Okay, so on the 1st of January 2017, t is equal to 0. So, we know when t is equal to 0, NA is just going to equal A, because we got e to the power of 0, which is 1, and likewise we know that NB is just going to equal B. So we can say that A plus B is equal to 290. Now we know that 1 year later, so when t is equal to 1, we know that the total number of trees affected is 331. Now we know that NA would be AE to the 0.1. So we know that AE to the 0.1 and NB is going to be BE to the 0.2. So we know that AE to the 0.1 and BE to the 0.2 is equal to 331. So what we have is simultaneous equations. So what we can do with this second one is divide through by e to the 0.1. Now that's going to give us A, add BE to the 0.1. We're dividing, so when you divide in terms of integers, we subtract. So e to the 0.2 divided by e to the 0.1 is e to the 0.1. So we get that is equal to 331 over e to the 0.1. Now, if we call this top equation 1, we call this equation 2, both equations have a single a in them, so we can eliminate a. So if we do, let's do equation 2 minus equation 1, then a take a is 0, and we got b e to the 0.1 minus b is equal to 331 over e to the 0.1 minus 290. Now, on the left, we can factorize. So we got b times e to the 0.1 minus 1 is equal to, now on the right, it's probably time to get our calculator involved. Okay, so the right hand side to one decimal place you should get as 9.5. So b is equal to 9.5 over e to the 0.1 minus 1, which is going to give you 90.3 blah blah blah, which to the nearest integer, happily, is 90 to the nearest integer. So, good news, it's a lot easier to find a. Remember that we know from equation 1, a plus b is 290. So, from equation 1, a plus 90 is 290. Therefore, a is 200. Cool. Okay, then part B wants us to estimate the total number of trees affected by a disease in 2020. So, in 2020, T is equal to 3. So, now we know our values of A and B, so we're going to get 200 e to the 0.3 add 90 e to the 0.6. Now to the nearest whole number we get 434. Cool. Okay, next up we want to find the year in which the number of trees affected by disease B will first exceed the number affected by disease A. So, we want then 90 e to the 0.2 t to be greater than 200 e to the 0.1 t. So we need to solve this for t. So let's first of all divide through by 90. So we're going to get e to the 0.2 t is greater than 20 over 9 e to the 0.1 t. Now if we divide through by e to the 0.1 t, we get e to the 0.1 t is greater than 29. Take logs on both sides, so we get 0.1t is greater than log of 20 ninths. Now if we multiply both sides by 10, we get t is greater than 10 log 20 ninths. Now that gives us t is greater than 7.98 if we go to 2 decimal places. Now this is just less than 8 years. So 8 years after 2017 would be 2025. So it's gonna happen right at the end of 2024. Cool. Okay, and then the final part wants us to comment on the long-term accuracy of the model. So, by the model, the number of trees is going to keep increasing. In reality, there are not an infinite number of trees in the forest, so eventually all the trees are going to be affected, which means then the model is no longer valid. So, say something like that, and you'll be fine. Right, that's the core done. On to stats. Yay, said no one ever.